All right, we've reached the final part of our Unit 4 course review, and that is systems of linear inequalities. So remember, with inequalities, you are shading. And not only are you shading, you are also drawing either a dashed line or a solid line. So anything that's less than or greater than, those are going to be dashed lines, whereas anything that's less than or equal to or greater than or equal to, those are going to be solid lines. Now, you could do this in Desmos. It will do the shading correctly, and it will do the dashed and dot for you, or dashed and solid. But you could also do it by hand if you understand how to graph these. So I'll do one by hand and one by Desmos. This first one, y is less than 3. Remember, this is your y-axis, this is your x-axis. So y less than 3 is basically like a horizontal line. If you're ever confused, imagine it was y equals 3. Y equals 3 is this line right here. It's a horizontal line because it cuts through the y-axis. However, we want less than 3, so we know we need to shade below in this case. So we would be shading in this region here. Now, the next one, this requires you to just remember how to graph a line. Again, treat this like y equals negative x plus 1 to start with, and we can shade later. So if you remember, that means you have a y-intercept, a y-intercept of 1, and your slope in this case is negative 1 over 1. So that indicates that from this point, you will go down 1, right 1, down 1, right 1, over and over. But you could also have started at your y-intercept and gone in the opposite direction. Up 1 and left 1, up 1 and left 1, and so on. And now this is going to be a solid line because it's less than or equal to. Okay, y is less than or equal to that. And shading underneath there, you will be shading below the red line. And basically your answer, everybody, is where you see the two regions overlap. So in this problem, the two regions overlap sort of in like the bottom left corner. So what a lot of people do is they show all their shading, which is fine if that helps you do it. Like you can write everything like I just did here, but be very clear about what your final answer is. So if you want to specify that this right here is the region that's the final answer, maybe put like this, like indicate to me that that's the answer. Or maybe you could shade over it with a darker color, or you could completely erase it like I just did and just say this is the answer right here. Or again, if we go all the way back here, just pick a different color and make it real obvious that that's your answer. So however you choose to do that, just be clear that your region you're talking about is very obvious. Okay? All right, now for this one, if we use Desmos here, one word of caution, I would at least write these in slope-intercept form, which means get y by itself. If it won't matter for this problem, but getting y by itself ensures that you don't accidentally like shade in the wrong direction, because if this were a negative y, we saw this in class a long time ago, when you like solve for y, the sign flips and you might be looking in the wrong region. So to prevent that from happening, let's get y by itself. So starting here, if I were to subtract x from both sides, I would have y is greater than or equal to negative x plus 2. That's how I'm going to type it into Desmos. And similarly, if I subtracted 4x here, I would have y is greater than or equal to negative 4x minus 1. So by doing that little step to start with, you'll be sure you're shading in the right spot. All right. So let's type those in, see what we have, and away we go. So y is greater than or equal to negative x plus 2. Y is greater than or equal to negative x plus 2. All right, that's right there. So you can see it's shading that. Now our second one is y is greater than or equal to negative 4x minus 1. So y is greater than or equal to negative 4x minus 1. And again, with Desmos, you can kind of see there's a light blue, a light green, and a dark green region. The dark green is what we're looking for in this case. So we are trying to find the point where the green and blue line intersect, which is right there. So negative 1, 3 is the point at which these two lines intersect, and then the shading falls into place from there. So if I go here, I know negative 1, 3 is the magic point. And again, to draw this accurately, you don't need Desmos for that. You could just draw the line negative x plus 2, which would start up 2 and have a slope of negative 1. So that's similar to the previous question. All right, and this is going to be solid. So here it is. And then this guy, the second one, negative 4x minus 1, that has a steeper slope of negative 4. So I can really only fit a few points on here. It'd be like this. So essentially, this guy right here. And if you're going to be greater than or equal to both of those lines, then you're going to be in this region right over here. All right, so that is how we could shade and graph systems of linear inequalities. Again, you can use this video to turn in this assignment as well as any other ones in Unit 4. This helps. There's a Unit 4 project, don't forget. This can significantly help you answer those questions. Okay? Best of luck to you, and I'll be talking